Well, here you've got the new Mavrik with all the changes we've made. Of course, the first thing we did is changing the slow fly propellers that obviously were not suitable for this kind of machine by cheap carbon propellers that are rigid, have a good aerodynamic efficiency, and of course they are capable of running at the RPM at which this drone driven when it is at full throttle. You've got control of gimbal. I'm going to disconnect it because to show you the bottom it is going to be crazy. Let's go now to see then the new mass distribution. If you remember, the original structure had these carbon tubes going from the rear part almost to here, where the gimbal was hanging of a very soft dampers. We always thought these two masses created an inertia momentum that was almost impossible to correct during the flight, because also the movement and the acceleration created by this mass was not in phase with the movement of the whole frame. What I mean with this is that all the masses, the huge masses of the battery and all the video and camera and gimbal equipment were holding from a soft damper. But that allowed everything to move, and the accelerations sent by these masses to the structure did not correspond with the acceleration that should be measured by the inertial measurement unit. So our idea was really simple. We only wanted to concentrate all the masses as close as possible to the center of gravity of the drone. So we took all the rear part, all the elements here, and we built some platforms of carbon of 3 millimeters to put everything in the place we think it should be. And the practical result demonstrated we were right. Now the battery, well, is held by this belt as well as this huge adhesive. Well, we built this platform. We also built this 3D printing leg to put also a third leg in the right place. We built this kind of well, not I don't know how to call it, foundations. What here this to hold the battery, and then I put the tubes. I use them to hold to build the landing gear, and this part is only a small piece of carbon that is also held by another manually made carbon fiber, which is now held here with these dampers that are made with very simple materials. They are made with rubber uh, pieces, or this kind of adhesive things you put in the legs of your chairs to not scratch your floor. It has a hole in the middle, and you can decide the tension of the damper by screwing and tightening more or less this this screw that has a security nut in the other side. Of course, we have added a lot of things. This is an LC filter. This is a platform to hold a video mixer and recorder. this is the supply battery for a thermal camera, which is in the front. We've got here a FLIR thermal camera, as you can see. We've got also FPV camera, and well, we've got video switch and shutter control, and well, and some other electronic equipment. Well, you can see this flies perfectly, and the modification is, well, let's say radical, but effective too. I only want to say that probably Steadidrones did a design, didn't test it, and once it was in the market, very few people bought it, and well, those who did it as we did are suffering the same kind of troubles. At least now you know where the problem is and how to solve it with not very complicated uh, repairing and not with very complicated things.